They will be talking about ITGS, which is that in the next 2 or 3 months, we are going to talk about the entire DP1. It's the entire DP1 knowledge on ITGS. So before we start, let's talk about the main thing. This is the main graph that we are going to be used frequently in the entire ITGS. It is called the ITGS triangle. Basically, it has three strands, which is just three parts, right? But ITGS loves to give fancy name. We all know that. The first part is called as social and ethical significance, which is the positive and negative impact that the computer raised. You may feel very confused, but I'm just going to give you a very simple of this. Computer, like we all use computer nowadays, right? Computer, it can make my life more convenient because like I can just type in the entire note instead of like literally writing 2,000 words, like in 2,000 word notes by hand, which is just very makes your hand very sore, right? However, the negative impacts also come. For example, if you use it, you may get addiction. You may be addicted to it. You may watch like TV shows, dramas, Chinese dramas for 2 hours a day, right? So that's just a social ethical significance. But the thing is that we also need to consider the social and ethical concern. You may be confused, like what's the difference between them? The social concern is just the concern that mainly causes problem to the society as a whole, while the ethical concern is mainly the problem that results in morality. That mainly results in a morality. So, for example, a social concern would be that, like, if you dump computer into the water, like if you dump the computer into the water, people will drink it and die. That's social concern. Ethical concern is on the morality. So basically, it's like if you watch computer for a long time, you will be addicted. So ethical concern, why is this an ethical concern? Is that because it doesn't affect anyone. Like let's say if I addicted to the computer, I watch it for 4 hours. Like it doesn't impact you. Because I watch it for 4 hours doesn't impact what you will do. Just because I watch it for 4 hours doesn't mean that you will like be suffering, right? So my action doesn't impact you. It only impacts myself to some extent. So that's the difference between the social and ethical significance. Now let's talk about the two application to specific scenarios. So it's just basically similar to the name. It's the area of society that is affected by the social impact, which is health, government, and business. So for example, let's say I use computer. Let's say, let's use the example of health. So it would be health use IT system to do what? It will be in a form like this. A specific scenario use an IT system to do what? So for example, it would be teachers, I mean the education system uses computer to host online sessions, right? That students can watch it anywhere, just like Zoom. Like because of the COVID, we have to watch like 3 years of Zoom. Like like our school just literally becomes Zoom secondary school, right? So that's just what we mean by application to specific scenarios. And now the third one, which is we call it strand three, IT system. It is the information technology that causes the social and ethical concerns. So basically, it seems complex, but it's just the system, the devices or the IT system that is being used. Yeah, the IT system that is being used. So that's what IT system means. So for example, let's say in this case, I'm using a computer to making videos. Then in this case, the computer will be the IT system. But this is called strand 3. Sometimes the teacher may start with strand 1, sometimes the teacher may start with strand 3, sometimes it will start with strand 2. But it doesn't matter. I mean, in the end, you will have to across like all the three parts. So in this case, I will be start talking on strand 3 first, which is the IT system. However, all those three strands relate to one thing, stakeholders, right? So basically, stakeholder is the people who is affected by those things. Like when we use the IT system, we use computer, it does not affect all the people. For example, when I play the computer, it doesn't impact my neighbors or my like people above me or people below me because like the fact that what I do with the computer doesn't impact them, right? So that's why in this case I'm the stakeholder. Let's give you another scenario. Let's say someone uses computer to input virus. Like let's say some hackers put virus on Reddit, right? In this case, what is going to be the stakeholder? Because the people who is using it's going to be first. It is going to be the user who's using Reddit. The user who doesn't use Reddit, it doesn't matter to them. Like if the Reddit hacked, if it's bankrupted, they won't feel anything. They even don't know there's something Reddit. There is something called Reddit. If I tell them like okay, the Reddit get hacked, they would like say, is it radish? Can I eat it? So basically, the people who doesn't use Reddit, they don't impact it. They are not being impacted by it. So they are not the stakeholder. But the user who is using the Reddit, they are the stakeholders. Let's say I always get on like our IPO to rant about how the IP is, right? If the Reddit gets hacked, like I can't use it, I will be impacted. So I'm the stakeholder. The Reddit boss, let's talk about another stakeholder. The boss of Reddit, he is the one that like manages the Reddit system, and he's the one that also makes the money. If the Reddit dies, he cannot make money. He will be bankrupt. So he will no longer be a rich person. So he's also the stakeholder. He's also the person being impacted. And finally, it's let me think. The developers of the system, because they are the one in charge of making it. So this is just an example of how the stakeholders work. Okay, after talking about all this, let's first start about talking about the first ever unit in IT system, chapter 2, hardware. So hardware, what does it mean? It represents physical parts of our computer system. So for example, a keyboard is a hardware. The thing that is completely in contrast of hardware is software, which is the application of our computer system. For example, Google Doc is not a software. Microsoft Teams, Microsoft Teams is a software. Google Docs is more like a cloud. Yeah, it's a more cloud-based storage, which we'll be talking about it on chapter 4 in the unit network. And software, on the other hand, we'll be talking about on chapter 3. Okay, so let's start. 3 steps in our computing system. Input, processor, output. Input is basically the thing that you put into the IT system. For example, let's say if I put in I love Google Docs. This is the input, right? The processor is that it's the information being processed by the IT system to produce the result. So basically, after I type in I love Google Docs, like the computer will process this string of words, and then it will make certain reaction. Let's say, for example, if Google Docs think it's an invalid code, he will just have an alert button saying, "No, you are bad." Right. No, that's personally output. I'm actually making a mistake. This is an input, right? So basically, this thing is in processed by a variety of the codes that teaches you how to do that. So for example, if let's say the code might be like this. If if I type in I love your dogs, it will just output you are bad. Else, blah blah. Right. So basically, the processor is just it's just a process of making judgments on what the system should output or what information should the system produce. Processor is the process of making judgments, right? Processor is actually the process of making judgments, okay? Output, on the other hand, is just the information produced. So for example, let's reuse the example of I love Google Docs, right? I love Google Docs. When I type it, the thing that will pop out is just on my eye, I can see that the I love Google Docs is shown on the screen. That is the output. Because when I type it, the system makes a judgment that the thing I typed should be shown on the docs. So that is going to be the output because it is shown on the Google Docs. Okay, it is the information produced by through the IT system. Now let's talk about some other things. Personal digital assistant. Personal digital assistant is quite normal in the like 20 years ago, right? But it's just not that popular now. So I don't know. I remember I haven't seen personal like digital assistant for many years. Okay, let's first to tell you what is this. It is a IT system. That's definitely correct. It is an IT system with a size between of a mobile phone and netbooks. Okay, mobile phone and netbook. So it's basically a size between phone and computers. The next thing is that it is usually used for quick input of information. So basically, it's just you put information like quickly and largely like this, and then it has an internet access, and it's usually used with a stylus, which we call this pen, and internet access with a stylus and a screen. Yeah. Now let's talk about the another hardware, that laptop and desktop computer. Desktop computer is the one that you used many some years ago. It is like relatively a big one, right? It is a big one. It's not portable. Like there will be a very fat, a fat square thing, which how I don't know what its name is. Like that, if you move it, it requires a very hard difficulty. So it's not portable, and it can be used for long periods of time, and it can be customized and upgraded. Laptop, on the other hand, is very portable. It's just like, for example, the one what we are currently using is iMac. What's that called? Mac, right? Yes, Mac. No, Mac is a system. What I call that to be Mac computer. Yeah, Mac computer. Mac computer is just a thing like it's very small and you can just move it very often. Like in fact, you can even put it in a bag. So basically, that's portable. The primary usage of laptop is usually used for simple internet access and word processing. Okay, so that's the difference between laptop and desktop. If you are asked about it, just say the first important thing that it's portable and importable, not portable computers. Okay. Now let's talk. Now let's continue to talk about the motherboard. Motherboard is just a board that connects the internal components. MAC address is a media access control. It is similar to an IP address, like it's 12 numbers. It helps in identify the device on the network. And then next thing is central processing unit. This is the brain of the computer. It's responsible for. It is responsible. I mean, it is the brain of the computer. It is the one that makes that processes. Okay, it's the CPU. CPU is the brain of the computer. It's a component of a computer system that controls the instructions, that controls the judgment of instruction. Component of a computer system that controls the judgment of instruction. And then it's the central processing, graphic processing unit. It's called GPU. It's a processor that generates high-end visuals. So for example, as you can see, like this is a visual, this is a visual. No, this is not. This is a visual. This is a visual. This is a visual. This is a visual thing. So basically, they are being processed by the graphic processing unit. So you can see those images, are called visuals. The main part that we are then going to talk about is the primary storage versus secondary storage. As you can see, primary storage is the storage that is directly connected to CPU. The examples include RAM and ROM. It's the secondary storage, on the other hand, the storage that aren't directly connected to CPU. The examples there are just CD. Let's talk about the difference between RAM and ROM. RAM is a primary storage that is volatile, which loses information when the system shuts, while ROM, on the other hand, is a primary storage that is non-volatile and read-only. Now let's talk about some other types of storage, which they are going to be commonly tested on. Okay. Optical storage, which its use is just use lasers to store information. An example of that is CD. Magnetic is detect or change magnetization patterns to store information. A blatant example is magnetic tape. Flash memory, lastly, is the use of electronic circuits to store information. Example is SD cards. Now let's talk about the file size. Basically, the file size is just the space the file occupies on a disk. If you have too large file, it will occupy too much space on the disk, so which will become overwhelming for computers to process. So the file size is divided into several categories: bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. Each conversion is, except the first one, it's 1024 to 1. What does it mean? The first one is 8-bit is equal to 1 byte. Think about this, because 2 to the power of 8 is 256. So let's talk about what bit is. Bit is one binary unit. So for example, you know that computer is all like composed. So everything we write is composed of computer one binary digits. So even though we see it, it may sound like, okay, it sounds like bit, byte. But in the computer, it looks like this. It may just, the thing like I type may just look like this. So 1 byte is equal to 8-bit. So basically 1 byte, so you can think about this. 1 byte is just a combination of 8. 1 byte is just a combination of 8-digit number composed of 0 and 1. If you think about it, that would make sense, right? So let's say, for example, B in the computer might be just 01011010. So 8-bit is just 1 byte. For the other thing, 1024 byte is equal to 1 KB. 1024 MB, 1024 KB is equal to 1 MB. 1024 GB is equal to MB is equal to 1 GB, etc., etc. So, but remember one thing, in some cases, it will be like some textbook or some teachers will say it's 1000 instead of 1024. This is basically inaccurate. It's because 1000 is just a simplification of 1024, so it's easier to calculate, right? But in fact, it should be 1024. It's the exact number, it's a 1024. But sometimes the teachers may ask you to write, like convert it in 1000 instead of 1024. So that depends on the teachers, right? It depends on the teachers. Okay, let's then talk about ASCII code. ASCII code is the definition of encoding system to store text. It is a numerical representation of the character. Each character is assigned from 0 to 127. So basically, it's just I'm going to show you an example. It's hard to explain it by words, so I'm just directly showing you an example, and you will understand it. ASCII code conversion table. As you can see, ASCII code conversion table. So basically, this is ASCII charts, right? ASCII charts. That is just shows like what each number, the ASCII number of each symbol is. For example, this symbol is one I, right? But in the computer, it's not I. Like the computer treats it as 161. Another example is B. Let's say, let me see, where is it? Okay, those are pretty unpopular tables. Let's say in this case 70 50 is 2. So for example, when you type in the letter 2, you may think that the computer considers it as 2, but in the end, it's actually considered as 50. Okay, it's actually considered as 50. So in this case, it would be, like in the computer would recognize it as 50. Okay, so let's go back to the notes. So I think here we come to the end of the first chapter of ITGS, and I hope you have learned a lot. See you next week. Bye bye.